In this paper, we introduce several key techniques that enhance the performance and efficiency of the Mistral 7B model. One of these techniques is sliding window attention, which leverages the stacked layers of a transformer to attend to information beyond the window size. By allowing hidden states in each layer to attend to previous layers within a certain range, we achieve a theoretical attention span of approximately 131K tokens. This approach results in a 2x speed improvement over a vanilla attention baseline for sequences of length 16K. Another technique we employ is the rolling buffer cache, which introduces a fixed attention span by limiting the cache size. By storing keys and values for each time step in a fixed size cache, we can effectively manage memory usage. The cache overwrites past values when necessary, preventing it from growing indefinitely. This approach reduces cache memory usage by 8x for sequences of length 32K without compromising model quality. To further optimize performance, we utilize the pre-fill and chunking technique. By pre-filling the cache with knowledge from the prompt and chunking large prompts into smaller pieces, we enable efficient generation of tokens one by one. This approach allows us to compute attention over both the cache and the chunk for each chunk, facilitating the generation of high-quality outputs. Our Mistral 7B model demonstrates impressive results across various tasks, outperforming previous models such as Llama 213B and Llama 134B. It excels in common sense reasoning, world knowledge, reading comprehension, math, and code tasks. Additionally, Mistral 7B achieves comparable performance to a Llama 2 model with more than 3x its size on reasoning, comprehension, and STEM reasoning benchmarks. Despite its limited parameter count, Mistral 7B shows a lower compression rate of 1.9x on knowledge benchmarks. We also explore the application of Mistral 7B in instruction-based tasks. By fine-tuning the model on instruction datasets, we create the Mistral 7B Instruct model, which outperforms all 7B models on MTBench and is comparable to 13B chat models. Furthermore, we address the importance of adding guardrails for front-facing applications. By introducing a system prompt to guide the model's generation of answers, Mistral 7B demonstrates responsible behavior. It properly declines to answer harmful questions when the recommended system prompt is used and exhibits the ability to perform fine-grained content moderation with self-reflection. This includes accurately classifying prompts or generated answers as acceptable or falling into categories such as illegal activities, hateful content, or unqualified advice. In our self-reflection evaluation, Mistral 7B achieves a precision of 99.4% and a recall of 95.6%. Overall, our techniques and advancements in the Mistral 7B model contribute to its superior performance, efficiency, and responsible behavior in a wide range of tasks and applications.